Welcome to Eventual Consistency, the show that cuts through the AI hype to talk about what's actually happening in data and technology. In this episode, which is a special one, we've got the CEO of Core9, James Winegar, being joined by two guests from Firezone, a zero-trust network access company. We've got Jamil Bou Khair, the founder and CEO, and Brian Manifold, who is a senior full-stack engineer. Between them, they spend their days understanding how trusted infrastructure becomes an attack vector, which makes them exactly the right kind of people for today's conversation. This episode is all about software supply chain security. The uncomfortable reality is that security posture isn't just about what's trying to get in from the outside, it's about what's already inside, embedded into your open source dependencies, the tooling, and the hardware that run your systems every day. James, Jamil, and Brian get into how the pressure to move fast creates the conditions for operational security to slip, how AI is fundamentally changing the calculus of both attack and defense, and what a genuinely defensible architecture looks like in that environment, from dependency management and credential hygiene through to zero trust segmentation and blast radius reduction. The question at the center of it all is, in a world where you are going to get breached, what determines how bad it gets? Here we go.
I mean, I feel like, security and it's inherently a compromise to the point I just said, right? Like I can make a system as burdensome as possible for engineers to do their work. It will be extremely secure if we do that. And so you're making the trade-off based off of like what you really need to do. And like as teams get bigger, it gets harder and harder to manage these things. So like probably one of the problems they had is static credentials existed somewhere. I'm not 100% sure, but they're not doing like, I'm guessing that there was like long-lived security token exists somewhere instead of OIDC for everything. Ensuring that only the repo itself could publish. Now they had access to GitHub, probably an admin account, so they could do whatever they wanted. But just those types of things in general, like could
things
help.
that slow you down. Yeah, things that slow you down.
And Jamil and I were talking about this yesterday too. There's always going to be some level of access that someone can gain that is just like game over, right? Because if they did have enough privilege in GitHub, it's kind of like even if they were using more dynamic credentials and stuff like that, yeah, it's just like, well, I'm just going to rotate this, or I'm going to add a user here, or I'm going to do this, right? I'm going to lower this privilege level, right? And at some level, everybody's vulnerable, right? And you just hope, not just hope, but like you're trying to find where those levels are that you're trying to protect, right? And like, okay, at this level, we have to absolutely do everything we can to protect it. Below here, maybe we don't have to be quite as intense because it slows down, like you're saying, it slows down the actual operations of whatever system you're in.
Yeah, one of the things I was thinking, because I mentioned air gap stuff earlier, is like, even air gapped environments have some risk. Like you can transfer data over sound and stuff like that. Like if you're really trying to, now it's a lot of work. Yeah.
Yeah.
Well, don't allow USBs, don't allow mounts, or I guess we talking Stuxnet, but yeah, like even if that air gapped environment, like, oh, we don't allow mounting USBs. Well, they probably still need install media. So there's a CD somewhere. Like if I just get that physical asset in there with malware on it, like somehow I got to get, stuff in there. Otherwise I don't have a computer. We got sticks and rocks. So,
it's a spectrum. Yeah.
Actually, I think this ties in with like, little geopolitics type of stuff, but supply chain attacks at the hardware level. Right, like the foreign router ban in the US, right? Like, TP-Link and Netgear and all these other, router manufacturers, like all that stuff gets, made in China. And so there's this argument of supply chain attacks and hardware. Well, go ahead, Jamil.
Yeah, I saw that the FCC, right? Allegedly, I guess, banned, or maybe not allegedly, but they banned new foreign-made routers. Now, I think there's a couple interesting things about this. First of all, so if you're making a router here in the US, you probably have foreign nationals like working for you anyway, right? So it's not like by setting the setting the borders to be within the US, you're suddenly now it's all safe, right? Like firmware can get in just as easily, right? To the extent, I don't know. I think the prices are obviously going to go up for consumer routers, but I mean, I guess I commend the spirit of it, because like everyone knows like insecure routers are a prime target for exploits. They become part of botnets, and there's millions of them, billions of them, perhaps even on the open internet. So
We were talking about this yesterday, Jamil, too, is like, even if you were building one on US soil, right? Where are you getting your chips from, right? Almost certainly not the US.
yeah,
Like the chances
Well,
of
I don't
you
think there's a
actually
fab in the
manufacturing.
US.
Exactly. That's
Right.
like, yeah, like there might be a couple, but they're not supplying to you. They're, if anything, they're supplying to the government or huge industry, right? Not the home consumer router
Yeah.
business. And
So
so,
what part of the pipeline is
yeah,
required to be in the US, right? Is it
well, and like that's the thing. The chip is at the heart of everything. Like if they alter the dyes that are, that they're making to make these chips, it's kind of like, what are you going to do? It kind of goes back to that, like at some level, everything is vulnerable. And I don't even know how you begin to guarantee that your chips aren't compromised, right? Um, there are probably some ways that you can, but I'm sure if you got sophisticated enough, you could hide functionality in a chip that wouldn't be exposed to normal testing, right?
Yeah, I'll bring up something. I'm not an expert in this category, yada yada yada. There's my legal attestation that I'm not, qualified to make the statement I'm making. But there was the thing with super micro,
I remember
and
that.
some
Yeah.
the chip
big scare.
manufacturer.
Yeah.
Yeah, it was like,
Yeah.
oh my gosh, there's like a radio on the motherboards that was not part of spec. I don't
Wasn't that
remember
like
what
a
happened.
wasn't that like a Bloomberg or like a Forbes article? And then it's like there was a lot of question around whether it was legitimate or not, and they never really. I don't know if they ever reached a conclusion.
I remember that happening. And I was at Cisco at the time, and I remember we were trying to work on a system where we could have photographs of every single board that came off the line. So that way, once it got to a customer, you could then like go back and say, wait a minute, something's different about this board than at the point of manufacture. Now, if they're putting stuff in at the time of manufacture, a photograph wouldn't help, right? Because obviously it would just look like whatever
Yeah,
came
well,
off
I
the
mean,
line. But
I mean,
go back to the design
Cisco
spec.
yeah.
as a supply chain. Yeah, when I was at Cisco, there was a lot of. I mean, there is a lot of security around, sealing boxes that get delivered to customers and putting all kinds of tamper-proof seals. Now, it's not going to stop the CIA or NSA from, right. Like they're going to still intercept it, tamper with it. Customer will never know, right. And so I'm sure there's stuff going on. I was never privy to any of that stuff, but
This is like we're not, we sound like conspiracy theorists right now. But
yeah. I mean,
this goes
it
down
happens,
a deep rabbit
right? I
hole.
mean, it
Yeah.
happens all over the world. So
somebody
but,
somewhere is interested in getting in somewhere else.
Yeah.
So
but as a dragnet, issue, I'm not. Yeah, the consumer router thing is kind of on a whole nother scale.
consumer routers, like when they're almost insecure by design, like almost, because like they never get patched. There's like the CVE happens 2 months after it gets released. Like your average consumer is not patching the firmware on their router,
Right, and
unless it's
in a lot of cases, you can't. Like my ISP here, they you've got to use their device, right? And so whether that hurts consumers or helps consumers, I guess you could make an argument either way. But
Yeah, I mean, it gets into the whole like security as a way to, you make things harder, right? So, okay, if the ISP owns it, then they're also responsible for the patching and maintenance of it. And if it's open, then it's, liabilities on them for issues. Now, like the big telcos, right? Like they're basically government entities. So, what's the actual like implication for them? Who knows? Another thing with like these consumer routers is like I think all the big players are going to get an exception, or besides maybe one or two, and it's like kind of forced monopoly kind of thing, right? So we'll see what actually ends up happening.
Interesting take. Yeah, very cynical. You just use it as a political tool.
Supply chain stuff is also important. So we talked about software supply chain, hardware supply chain is another big consideration. The AI tooling just gets better, faster, stronger in exchange for more resources, more power, more energy, more memory, etc. And like, the way that this stuff goes, like we can always just if we can add more and we add more, it'll be faster and we can do more. And so as long as like the capability exists to use more, like they're going to be using more to train better, bigger, better, faster models.
Yeah.
Agreed. Yeah.
Yeah. I mean, I'm guessing I would be blown away to hear that you're not like daily driving, 8 hours of your days, using Anthropic or, OpenAI or one of these providers to help you.
The way I use AI and the overall, is it saving time? Yeah, I could make that. It's not saving time as much as it could, for the following reason. Anything that AI generates, you have to go and manually verify, right? So to the extent that what you're working on is critical, right, and needs to be accurate, right, the verification time goes up. So if you're writing some very critical piece of code, like you've got to still step through line by line. Now you're doing code reading instead of code writing, right, which is a different part of your brain and almost more draining, right, because you're not thinking through it at the same sort of level of detail.
I mean, it's just one constant code review after another, essentially.
Yeah, very taxing mentally.
Yeah. And so I do wonder if we're actually, getting hit from both sides from the security spectrum. Both we're generating more code that we're not reviewing, and then also now the attackers have these automated tools that can look at other people's code and then also come up with a proof of concept potentially. Again, It might not work perfect, but if it spits out 90% of the proof of concept, and then all they have to do is like fill in the 10% left of like, how this thing actually could be exploited.
Which
That's
is also how
big
you write
win
your
for the bad
code
guys
right now.
Right. Yeah.
We've been working with some customers on product development, and like there's been some bugs that have happened within their environment, and the people who were not doing appropriate levels of validation, you can find the source of the bug and go back and hey, here's what you did, etc. But there's another thing here about just like best practices in general, and like how do you enforce those practices kind of across the board. Like a lot of historic pre-AI best practices was like type systems. Like type systems get rid of a whole set of bugs that can happen. Static analysis tools, linting,
Writing tests.
like, writing test cases, like
QAing your software
even. Yeah, which is just another higher level of testing, right? Like, at what level should the test cases be? Like, is it a unit test? Is it an integration test? A UI test, like, does my front end, hold state correctly when, I do this type of change? Like, there's a whole class of exploits just because, like, people can, do something on the client side and exfiltrate on accident, right? Software just gets more and more complicated. Like one of the things about software that's interesting to me anyways is that for the most part we're not bounded by physical reality. Like when you need to build a house, you need a foundation. Now, like a lot of software engineers would argue, yes, to build software you need a strong foundation, but do you have to have one? Is it fundamentally required for it to exist, right? Or does it look like, a bunch of Lego blocks that kind of got thrown together and, there's a cylinder holding up, the Pantheon?
So with the rise of LLMs, software is becoming very cheap to write. That's really the only thing that's changing. It's cheap to write, cheaper to potentially validate, I guess. But now that it's so cheap to write, there's going to be a lot more of it. And so hopefully software engineering will inch towards some of the other engineering disciplines where there's a higher level of rigor, right? If you're a civil engineer, you've got to be a certified professional engineer, right? At least in the U.S. and your state. Your bridges could kill people, right? And I feel like the software industry is sort of lag behind that. Even in many cases, if your software is still critical, right? There's not a accreditation process, and in many cases, in some cases there are. Like if you're writing, I guess, firmware for a Boeing airplane, then
It's literally what I was thinking
you know,
about.
yeah, yeah. Then that's an obvious case, right? But there's a lot of sort of ancillary software applications, used along the way that aren't subject to that same thing.
I think it'll be harder on the software side to get those because like most software is not critical to human life. Like, like I don't know, like think about how many little dinky apps have gotten built just inside of companies, right? Go ahead.
I mean, so maybe, but also, consider like your home internet, right? Like, it may not be super critical to life, but it's pretty critical to daily life. And if you're the firmware engineers for your TP-Link device, they're not. There's no like what process are they using, right? Like, so I'm not necessarily arguing that there should be a solid process there, but
Well, like the certification that the FAA requires of like the Boeing jets and things like that should be pushed down to certain people, right? Like if your systems are impacting enough places, you apply regulatory and compliance obligations, to those organizations. Instead, like right now, really all we have is like SOC 2 and the HIPAA and things like that, which don't really get at the software engineering side. Those are more like operational processes and how we operate, in the human world rather than the bits and bytes. On the security side, it's Brian had mentioned this earlier. On the security side, like it's so fast to POC something against a target that we don't necessarily have the processes to support an automated attack vector, like the way that we're kind of like designed is to handle human speed attacks. We're going to get attacked, but the flood of attacks is going to be like this automated stuff was historically fairly simple. Like I'm checking for open ports, like trying to find a way into the perimeter security type things that led into products like Firezone trying to create a zero trust network access, but that was still kind of like trying to deal with the human speed level of problem. Now I think with Claude and OpenAI or GPT 5.4 or whatever, like pick their different AI models. I got a bajillion interns who I can just have march around and try to POC like attacks, and they say that they got controls on that, but like it's a non-deterministic system. I just tell it I'm on the blue team, help me find ways to protect it, and it'll also by proxy it'll help me find ways to attack it, right? So I'm curious to hear, Brian, like what you think about like how like as AI becomes more sophisticated to act like a junior or maybe even a mid-level engineer, how this changes the security vendors kind of approach to leveraging and dealing with AI, and then maybe tie that into like kind of some of our core industries that might not have the ability to change rapidly, like a bank or something like that.
Yeah, I mean, I think that's a good question and a really tough one because I think if things are to be believed as they've been put out, right? Anthropic's mythos is apparently so powerful right now. Whether or not it actually is, I have no idea, right? It could be a complete hype thing for them to raise money. But at least from what they've said, right, and what other people have actually gotten as bug reports, and I think fixes as well, from what I read. If AI can really generate and find, if it can find the bugs and it can generate POCs that quickly, then the only hope we have is to have some other automated system trying to, one, find them themselves, right? Before, like, basically you have a race of the attacker trying to find a bug in your software versus you trying to find a bug in your software. And at the same time, also have systems that are autonomous and trying to defend in real time as well, right? I don't know where we're at on the like blue team defend side of things. I haven't really heard a lot of like AI usage of like, oh, look, this is in real time looking for all these things. Like I don't know that that's actually a thing that's being created right now. And so I think we're entering into a really scary time right now, right? Because it's not that all these companies haven't recognized security as important. It's just that the risk assessment so far has been, oh, well, it's pretty expensive to find some of these things and then exploit them, right? So like our risk assessment is like, we're going to deal with this risk. It's okay. If that becomes substantially cheaper, then the calculus of your risk assessment just goes right out the window. And I don't know exactly how we fix that other than, okay, we need to, I guess, start trying to find our own bugs as quickly as we can. That might be what ends up happening. Maybe we'll see more red teams, like automated red teams come online with companies to try and find bugs. And now the question is too, how do you fix them fast enough? Hopefully the AIs can, like as you find them, they can fix them just as fast.
To tie it back to the beginning when we were talking about it, incident response becomes critical because you're going to get popped, right? Like the likelihood of you getting popped goes up, right? How you handle that is just as important, if not more important. So yeah, if your credential gets leaked, you need to rotate all of your credentials. So
I think even to tie it back to further the supply chain stuff, maybe instead of, we were talking about having more structure in place of how code is written, maybe rather than how code is written, it's more of how things get brought in, there's a more formalization of the supply chain type of things. Maybe that's where things need to go. Not that it's a bulletproof system, but like maybe that starts to help. I don't know.
The whole onion model too, though, for security, right? Like people are just going to have to have more layers, which is going to create more burden for engineers, which will hopefully standardize some of the processes, which will hopefully tie into be more professionalization of software engineering. But like, how does the system respond to step changes happening every few months?
I mean, I think we might look back, in 5 or 10 years and go like, it's so crazy that we just like installed, 100 dependencies from random people in our software. And we check these boxes, and then it's like, oh, it's there's no CVEs out for it, and we follow these lists or whatever it is. That's not a perfect system, and so perhaps with LLMs, maybe the industry will move to writing more of that software from scratch, or vendoring some of it, right, or recreating the wheel a little, reinventing the wheel a little bit, because it's cheaper to do so.
We're already seeing a bunch of vendoring in the front end ecosystem too, right? Like Shad CN, I think, like vendoring components, like when you instantiate your product and you evolve them how you need. And so you really only need to do that security review at point in time instead of constantly, as far as like the external dependency. But human laziness is real, but like less and less code is also being written by humans. And so like, you can kind of prompt, for at least for these smaller dependencies to be like, hey, just build it yourself and write appropriate test cases for that. But, I'm still going to need to bring in like NumPy as a dependency because it's got, very, very advanced algorithms for doing math as computationally efficient as possible as compared to like, raw Python matrix multiplication. It's just not going to do it.
Yeah. Jamil and I were talking about that yesterday of like being able to produce your own version of a given library, that'll help up the entropy of all software, right? Because if everybody's pulling in this one library, then an attacker with AI just needs to take that library, point the AI at it. And now if they found a bug in that, they found it in a bunch of different products, right? Potentially anyways. And now if you've got more code being written that's specific to your product, right? The entropy of like, well, okay, they still could point an AI at my product, but I've got to be worth it, right? And so it's not as easy to just say, oh, I'm just going to grab this library, point the AI at that, find the bug there, and now I can just boom, 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 find all these other things, right? So that might be one way that we can sort of mitigate some of this that could be coming at us, is having it generate more of the code rather than just pulling in dependencies.
Yeah, I feel like whenever I talk about the AI stuff, like in the like what's going to happen in years from now, it's like trying to get the crystal ball out, like
Sure.
I'm profiting instead of like really got an opinion. Like I feel pretty confident about 3 months.
Yeah, for sure. Yeah.
Yeah, I mean, if it's a matter of dollars spent, I mean, they're going to spend the money, right, to power these. They're going to spend the money to run these things, to find vulnerabilities, right? So before an attacker does, right? I mean, for all we know, there's a bunch of ODAs out there being exploited, right? And Mythos, it goes back to the hype, right? If you put the hype aside and you actually believe what they're saying, that it is critical software that they found vulnerabilities or ODAs in, and then they took the responsible approach, right, working with the vendor directly. So it's like almost like a responsible disclosure on a massive scale, in a sense. Then yeah, I mean, I think that's a plausible narrative to me, right? I think that could have actually happened, right? The question is that I have is, how does that play out over time, right? You can't just every time you have a step function, okay, and now we're gonna run a billion or a $10 billion compute run. Find all of these vendors that are running that have critical software that we want to notify them about, and then like at some level, like this needs to be a continuous thing, right? If it really is providing that much value, and then like how do you shrink that time frame down? Like, is that actually going to get down to the engineers? Is this going to be a tool that an engineer can run and go, oh, great, the software I wrote is secure, right? And if not, then like, is it ever going? Then is it going to be more secure, right? I don't think we're going to get like a consistently, I think maybe I'm just being too cynical, but I don't think we're going to consistently see more secure software as a result of this.
Yeah, not for a while, anyways, right?
Until this becomes let me know when it becomes a GitHub action that I can just include in my workflow, like run Glasswing or whatever it is, and run Mythos.
The problem is it's going to cost you $1,000 to run that PR review.
Well, hey, that'll start there, and then I'll use my startup credits to subsidize it.
That brings in a whole other thing, right? Like how much this is all being subsidized right now. Like what's the true cost of all this at the end of the day? Yeah, exactly. And so like, is this even going to be economically feasible in the long term?
Right.
I don't know, right? Like, I don't know.
Looking into my crystal ball, right? Like, it's only going to be for the big tech companies or the banks, and governments, big tech companies, banks.
If you have a service and you don't need to expose it on the public internet, obviously you should shield it, right? And that includes your VPN endpoint. And I think what I've learned is that kind of my thinking on this is that it's you can only defend so much. You are going to get hacked, so it comes down to detection response, and I think that's where I would advise people to
blast radius
to focus. Yeah, blast radius, reducing the blast radius, so keeping firewalls between components, and I guess that plays into zero trust as well, right? You want to segment and use principle of least privilege, right, as much as possible. So having a VPC in your cloud where just everything can talk to everything is probably not a great idea, right? So have firewalls down to the individual component level.
I would agree, and I would add to that. I mean, I think I spoke a little bit to this earlier of companies previously could get away with maybe not doing defense in depth because of the risk calculation of like, well, it's expensive to find this vulnerability and this vulnerability and this vulnerability. If that ability to compromise a multitude of things becomes a lot cheaper, defense in depth is much more important for any company, right? And to tie back to our product, right? I mean, that's what Zero Trust kind of helps with, is like, you don't just get in through the front gate and then get access to everything. You now have access to this one specific thing or these two specific things, right? And so, I think that's going to just become more and more important as we go forward.
People need to take more time to think about their systems and how they need to interact with each other versus just the opposite of spray and pray, but like kind of the same idea, like just hoping that it all works out at the end of the day. Perimeter security is basically what that is.
Right. And I mean, I get the allure to just be like, yeah, just let it connect up. And then all of a sudden it's, hey, we got something working. It's great. Right. But then it goes back to that whole like security versus usability, right? Like whichever way you lean towards, you're going to affect the other, right? So if you go too far on the usability side, well, your security is probably too lax, right? But if you go too far on the security side, well, your usability is going to suffer, right? And so I think companies are going to have to they're going to have to take a harder look at that and say, where do we set that dial now? Because it used to be that we didn't have to worry about it too much. Now we really need to worry about it.
You've done a lot of pinning of versions for, your cargo dependencies for Rust, your GitHub Actions, etc. Because it's built into the way you're able to do things. But you've also vendored some dependencies to kind of reduce blast radius, etc. Give you the ability to resolve various issues that you've had with them. Do you feel like there will be a lot more vendoring that y'all will have to do as time goes on, kind of related to the same ideas we talked about today?
For every new dependency we bring in, we definitely give it a higher level of scrutiny. All right, so go read the code, understand who's maintaining it. Obviously make sure the shot pinning is happening, and then we also, what we did recently, we implemented a cooldown period, right? So we'll let something sit, for a while, and every organization is going to be different, right? But I don't think, depending on how you've configured Dependabot, you may not want to pull in a dependency right when it's cut and released, right? For not just for security reasons, just also for stability, reliability. So yeah. So those are some basic things. I mean, I would also add, a lot of people don't know this, but a lot of the SaaS apps that you use around the internet, they have an IP allow list feature, right? So like not just GitHub, but Slack and even like HubSpot. And you can configure that to allow connections only from a certain range of IPs. And so you could set up, a lot of our customers are doing this. They'll set up their Firezone gateway, right? They'll route those apps through Firezone, assign that gateway a static IP, and then now you can only use those apps if you've got Firezone installed and you're signed in and whatnot. So an external attacker wouldn't even be able to get to your application, right? Your tenant.
I mean, that's literally how we use Firezone. So like it's to force exactly that. So.
Yeah, I think we've also gone back and taken a look at some of our existing dependencies and said, can we get rid of some of these and can we rewrite them, right? Now, that one's harder because, like you just said, Jamil, like that means we're changing functionality that already exists. And so we got to be careful of like, are we actually, regressing in some way? But it is conversations we're having where we wouldn't have had before, right? It just would have been like, yeah, dependency, use it.
Yeah. How many left paths you got, right? Versus like kind of core infrastructure dependencies.
Right. Yeah, that's one of the core things, right? If I'm bringing in a dependency to use one or two function, I go look at it and I'm like, I could just write this. Like Claude could write this in 30 seconds.
That's it for this episode of Eventual Consistency. If you want to talk about your data security challenges or you think we got something wrong and want to tell us how, you can find us at core9.com. We're back in 2 weeks, and we'll try, as always, to be a touch more consistent. Thank you for listening.